Right, question 15. This is question 15. So it's explaining the key points on this graph. Right, skydiver. Okay, skydiver jumps from an airplane, accelerates until she reaches terminal velocity. Right, this again, this might be. This is probably a little bit unfamiliar to a lot of you because it's not a velocity time graph. Like I said, any graph, check what's on the axis. This is an acceleration time graph, which we don't do enough of, I think. Okay, right. So it nuances to look at the graph. It's a skydiver. Explain the key features of the graph. Explain the shape. But we have to refer to forces acting on the skydiver. Okay? Right, so let's just identify, let's talk through, let's describe the features of the graph first, because I think that's always a good start, and then we can explain them individually. Right, at the start, acceleration is maximum. Okay, so we've got a positive acceleration, so it looks like we're going to be taking downwards as positive here. Okay, right, at the start, acceleration is maximum. Then acceleration decreases, okay, until it reaches 0. This is when we're moving now at terminal velocity. Okay, there comes a point, right? They fall at terminal velocity. They fall with 0 acceleration until this point here. What's happening now? We then have a big jump in negative acceleration. We've got a big acceleration, a big sudden, rapid acceleration. Now, if that's negative, it's upwards. Okay. Then the acceleration rapidly falls to 0 again. And it stays 0 because we've now reached our new, thankfully slower terminal velocity with the parachute open. Okay, right, that's not answered the question now, has it? All I've done is gone through and identified the different points that I need to explain by referring to forces. That's how you answer the question. Right, so let's take this one here. First point, we've got a maximum acceleration because the resultant force is maximum. Now, at the start, we have a skydiver falling. At the start, there's going to be 0 or very little air resistance upwards, so the resultant force is just the weight. Okay, as he speeds up, air resistance will also increase until air resistance or drag now equals the weight. Now forces are balanced. Don't say equal. Do not say equal. Those forces are not equal because they're in opposite directions. Okay? For two vector quantities to be equal, sure, they're equal in magnitude, but they're in opposite directions. Please say balanced. Those two forces are now balanced. That's why we reach terminal velocity at this point here. Okay? Right, parachute opens. What happens when the parachute opens? We then have a huge upwards force. The resultant force is now upwards, producing an acceleration upwards. Okay? So that's what produces this point here. Okay? But as he slows down, because the resultant force is upwards, he's going to decelerate. Okay, he's going to, didn't mention that before. A big negative acceleration is actually manifests itself as a very rapid deceleration. So, but as he slows down, drag slows down rapidly until the two forces are, wait for it, balanced again. Okay, and they're balanced again, and we reach this point here. Okay, so there you go. So all I did, I identified the different points I wanted to talk about, and then I've used or referred to forces to explain. Yep, always, always, always answer the question. Might sound obvious. Okay, so question 15, done.